Hello, today we're going to be talking about two different topics. First, the angles of a triangle, which is found in your textbook on page 494, and also irrational numbers. In your book, this is actually called real numbers, which is section 9.4 on page 496. So, the first bit about the measures of the sum of the measures of the angles of any triangle. So I have a little demonstration here. If you take any triangle of any shape, and a triangle has three sides, we call these the vertices. If you were to tear off the vertices, and I recommend you doing this, might as well, and then put the vertices together so the points line up, you can see that the sum of these angles, well, if I could get that to stay like that, form a straight line. Okay, they form a straight line. And how many degrees are in a straight line? That's 180 degrees. So this triangle was that shape. Here's another triangle, just to show you that it does not matter what type of angles you have in your triangle. If you take any triangle, tear off the vertices, and then line them up, it forms a straight line. It's just a great way of showing that the sum of the measures of any triangle are going to add up to 180 degrees. Okay, that's a key point. The sum of the measures of the angles, I should put here, the three angles of any triangle is 180 degrees. All right, so what type of angles do we have? An acute angle, is less than 90 degrees. And a triangle would be called acute if all three angles are acute. Okay, so we have an acute triangle if all three angles are acute. A right triangle, is equal to 90 degrees. And a triangle is right if there is one right angle. You can't have more than one right angle because more than 190, 90 and 90 would be 180. That's all your angle degrees are used up in two angles, so that wouldn't work. So the most right angles any triangle can have is 90. Obtuse, you probably know this, is an angle that's larger or greater than 90 degrees. So an obtuse triangle has one obtuse angle. An obtuse triangle has one obtuse angle. And then the last type of triangle is equiangular. That means all three angles are the same. And we'll learn that equiangular also means equilateral. But think of this with me. If we have three things that add up to 180 and they're all the same, then each angle would be 60 degrees. So an equiangular triangle has three equal angles, and they would all be 60 degrees because 60 times 3 is 180. So these classifications are in your book. Just running through them here. Okay, I love geometry because you get some really cool pictures like this, and it's like a puzzle. We have to use some logic and deduction to figure out what are the measures of these angles. So here we have triangle ABC. This also is in your book on page 495. if you want to look at it, page 495. I've copied it down. So here's a large triangle, here's a smaller triangle, and here also. So we've got 3 triangles going on here. And we're going to use the fact that the sum of the measures of all 3 angles in a triangle is equal to 180. We're going to try and find out what is the measure of angle X, angle Y, and angle Z. So if we were to look in this triangle here, we have 2 unknowns. We can't solve that with 2 unknowns. If we looked at this big triangle, we've got also 2 unknowns here, so we couldn't solve that. So if we start over here in the small triangle, and we know that one angle is 100, one angle is 60, so we could find the measure of angle X. We would take 180 minus 100 minus 60. You could grab your calculator or do the math. That is going to be, angle X is going to be 30 degrees. Angle X was 180 minus 100 minus 60. Oh, that's not right. That's 20 degrees. Hello, I got it. Okay, so angle X right up here is 20 degrees. Okay, how does that help us? Well, it doesn't really help us. We still have 2 unknowns over here. All right, here's a little trick. Do you see these 2 angles here? They are called supplementary angles. When they are right next to each other, that's called adjacent, and they add up to a straight line, then we know that these 2 angles are going to add up to 180. So if this angle is 100, angle Y then would be 80 degrees. 180 minus 100 leaves us with 80. Now that we have Y is 80, now we can find the measure of angle Z. So we're going to add these up. 30 and 80 is 110. So angle Z is going to be 180 minus 110, or 70 degrees. So we were able to find the measures of all of those angles. Now your homework problem will ask you then, classify the triangles according to their angles. Are they acute? Is it an acute, a right, an obtuse, or equal angular triangle? So let's take a look at this. We've got a 30, an 80, and a 70. These are all acute angles. So triangle ABD, or triangle ADB, or triangle BAD, or BDA, or any of those arrangement, those 3 letters, this triangle here would be acute. This triangle is acute. Let's take a look at the large triangle. We have a 30. This added together would be 70 and 20. Oh, this is actually a 90. And here's angle 60. So triangle ABC would be a right triangle because we've got a 90 degrees right here. And then looking over here at this triangle, triangle BCD, we have one angle that is greater than 90, so that's obtuse. So this triangle here would be an obtuse triangle. It's hard for me to write that the big one is right, but okay. Moving on, that's it for triangles. We're moving on to section 9.4, which talks about real numbers. We're doing 2 sections because there's not a whole lot of information in either one. So the set of real numbers is made up of the set of rational and irrational numbers. Rational and irrational. So we defined before, a rational number is any number that can be written as P over Q, where Q is not equal to 0. So a fraction, what do those numbers look like? Well, you have whole numbers. The first whole number is 0, 1, 2, 3, ... Those are the whole numbers. Rational numbers also include the integers. The integers are the positive and the negative whole numbers. So we could have ... -3, -2, -1, 0, 1, 2, 3, ... It's like a number line. Positive and negative whole numbers, those are the integers. Fractions, of course, you know what a fraction is. 1/2, 2/5, 30 over 27, maybe it could be reduced. All right, all of those are fractions. Mixed numbers, 1 3/4. Those are all fractions. These are all rational numbers. We have decimals that end. Sometimes we call that terminating. So we could have 4.2 is a rational number. This can be written as a fraction, right? We could also have repeating decimals, 0.333 repeating, because we know this is equal to 1/3. And we talked about this before. We had that lovely test where we had write the fraction, change from a repeating decimal to a fraction, if you remember how to do that. Whoops, fractions at n, the repeating, I meant to put right down here. Those are all rational numbers. So what number is not rational is called irrational. And the definition, this is a symbol here for definition, DEF little n. An irrational number has a decimal that goes on forever and never repeats. So if rational numbers have decimals that end or repeat, irrational numbers don't end and don't repeat. So what are some examples of irrational numbers? Well, the most famous probably is pi. Some of your classmates know several digits of pi. The square root of 2, square root of 3, square root of 5. There's many, many, many irrational numbers. The square root of any number that's not a whole number would be an irrational number. There's also a number that is denoted by the letter E. And when you get into about Algebra 2, you'll learn what E is all about. So these are irrational numbers. I'd like to do the checkpoint with you on page 496, if you would turn there real quick. And it just says, tell whether the number is rational or irrational. So the first one is 2/3. 2/3 is a fraction, so this would be rational. The next number is the square root of 100. Well, is that a perfect square? Sure is. Square root of 100 is 10. So that would be also rational. This is rational. The next number is the square root of 6. Well, is the square root of 6 a perfect square? The answer is no. So this would be irrational. And the last number that they give us, or expression, is the square root of 16 over 25. Well, the square root of 16 is 4, and the square root of 25 is 5. So since that does simplify to a fraction, this would be rational. All right, I will load the homework on the Google Classroom page, and good luck.